This video is presented to you by www.testprepadda.com. Dear students, in this video lecture, I will talk about the concept of average atomic mass and average molecular mass. First of all, average atomic mass. Now, why do we study average atomic mass? And where do we use this? Many elements have isotopes. For example, you must be aware of carbon 12, carbon 14. So carbon has got these isotopes. Chlorine Cl35. You must be aware of Cl37. Chlorine isotopes. Hydrogen isotopes. You must be aware of 1H1, 1H2, 1H3. For these elements, we do not write individual atomic masses. Depending upon their percentage abundance, we find average atomic mass. These elements are present in different abundance in the atmosphere. So, first of all, the term average. You must be aware of the term average. In a mathematical way, if I ask you, for example, if I say Raju has, let us say, 10 rupees, and Mohit, let us say, has got 20 rupees, then what will be the average? It's very easy. Average money will be 10 plus 20 upon 2, and that is 15. Now another example, again a mathematical example. If I say in a classroom, let us say 20 students are there, 20 students, and out of 20 students, 5 students have got, let us say, 10 rupees each, 10 rupees each, and 15 students have got, let us say, 20 rupees each, 20 rupees each. So what will be the average money? The average will be what? Total money upon total number of students. Total money will be what? 5 students, 10 rupees each. So I'll write 5 into 10 plus 15 students with 20 rupees each. So 15 into 20 upon 20. So it becomes 350 upon 20, and the value comes as 17.5. So this is the way we find average, and the same concept I'm going to use to find the average atomic mass. For example, if I take chlorine, if I try to find average atomic mass for chlorine, chlorine has got two isotopes, Cl35, Cl37, and the two exist in the ratio 3 is to 1. 3 is to 1 in the atmosphere. So for the average atomic mass, what will you do? The atomic mass of Cl35 is 35 into, what is the number? 3 I can take, plus here 37. I can write 1 for this, upon what will be the total number? 3 plus 1, that is 4. So this way, if you solve, the value comes as 35.5. This is the way we find average atomic mass. With the help of this example, I will try to find a generalized formula for average atomic mass. Consider uh, three elements in a container. Let us say three elements A, B, and C. and let us say the number of moles of A as Na, B as Nb, and C as Nc. So what will be the average atomic mass? The average of the atomic masses will be what? The number of moles of A into atomic mass of A plus number of moles of B into atomic mass of B plus number of moles of C into atomic mass of C upon the total number will be Na plus Nb plus Nc. Okay, now if I write this for n elements, let us say n elements are in the container. So in a general manner, I can write this as the sigma summation mole moles into atomic mass upon Na plus Nb plus Nc so on can be written as summation of what? Moles. So this is the formula for the average atomic mass. This we also say as atomic mass of mixture of different elements. Now, if you divide this Na plus Nb plus Nc here, this average atomic mass can also be written as Na upon Na plus Nb plus Nc into atomic mass of A plus Nb upon Na plus Nb plus Nc into atomic mass of B plus same I can write for C. Now if you look at this, this is what? Moles of A upon total number of moles. So it is a fraction. Fraction of what? Moles. So it can be said as the mole fraction of A. Mole fraction of A into atomic mass of A plus mole fraction of B into atomic mass of B plus mole fraction of C into atomic mass of C. So in a generalized manner, what can we write? Average atomic mass as the sum of product. Product of what? Mole fraction into atomic mass. So this is another generalized formula for the average atomic mass. Now, one more way to find average atomic mass is what? If the percentage is given. If the percentage abundance of different isotopes, or better I say different elements given. Percentage of what? Percentage of total number of atoms. So average atomic mass in that case will be written as percentage of A into atomic mass of A plus percentage of B into atomic mass of B plus percentage of C into atomic mass of C upon what is the total percentage? 100. My point is clear. So in a generalized manner, if I write average atomic mass here, it will be what? It will be summation of percentage of the element into atomic mass of the element upon 100. So these are the different ways to find average atomic mass. Now in a similar manner we can write the formula for average molecular mass, or molecular mass of mixture. So if a mixture consists of different compounds A, B, C, so on, so average molecular mass can be written as in the very similar manner summation of percentage of 1 into molecular mass of that upon 100. In terms of moles, we can write summation of product of moles, molecular mass upon summation of moles. In terms of mole fraction, I can write this as mole fraction into molecular mass. So if there are three compounds A, B and C, I will say this as moles of A into molecular mass of A plus moles of B into molecular mass of B plus moles of C into molecular mass of C upon total moles means Na plus Nb plus Nc. My point is clear? Now, I will take few examples here to understand the concept of average atomic mass and average molecular mass. Here the question says the percentage abundance of isotopes Fe54, Fe56 and Fe57 are 5%, 90% and 5% respectively. What is the average atomic mass of Fe? Here we simply use the formula of average atomic mass of percentage. This Fe54 is 5%, so I'll write 54 into 5 plus 56 is 90% plus 57 is 5%. The total percentage will obviously be 100. So if you solve this, the value comes as 55.95. So this is the average atomic mass of Fe. Now I'll take another question here. Here the question says boron has two isotopes B10 and B11 in the atmosphere. Find out the percentage of B10 isotope if the average atomic mass of boron is 10.8. In this case, the average atomic mass is given and percentage has been asked. So, I will say, let us say here, let us assume the percentage of B10 as X. So obviously the percentage of B11 will be 100 minus X. Now I will use the formula average atomic mass, that is the percentage of B10 into 10 plus percentage of B11 into 11 upon 100, and this value is given as 10.8. So if I solve, it will be 10x plus 1100 minus 11x is equal to 1080, and this way the value of x comes as 20. So the percentage of B10 isotope in the atmosphere is 20%. Okay, now I'll take another question here. Here the question says, in a chamber, ozone is getting converted into oxygen. 10x percentage of initial ozone is decomposed and average molecular mass of the mixture. In this question, it says average molecular mass of mixture is found to be 40. What is the value of X? Initially it says it is 100% ozone, and after some time 10x percentage of ozone is decomposed. So if I write the reaction, ozone getting converted to oxygen, if I balance, it will be 2 here, 3 here. I will say initial as 100. This was 0. After some time, the 10x percentage decomposed. As you see, 2 ozone will give you 3 oxygen. So 10x will give 15x. Okay, so now ozone, the number of moles you can say 100 minus 10x, while oxygen is 15x. So if I use the formula of average molecular mass, it will be what? Number of moles of ozone, that is 100 minus 10x, into molecular mass of ozone, that is 16 into 3 means 48, plus the number of moles of oxygen into molecular mass of oxygen upon total number of moles, now means 100 minus 10x plus 15x. This value is given as 40. So if you equate the two, the value of x, if you solve, the value of x comes as 4. So this question involves the concept of average molecular mass. Dear students, if you feel any difficulty in the concept of average atomic mass or the concept of average molecular mass, please let me know at teacher at the rate of testprepadda.com. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.